Hello, my name is Kadarasu Rohit Vaikunda Sriram. I am from CSC Data Science Department and my roll number is 47. My applied physics AAT topic is separation between successive HKL planes. Understanding the separation between successive HKL planes in crystallography. Introduction to crystallography. Let us talk about the introduction to this. In crystallography, understanding the separation between HKL planes is crucial, and this concept helps in analyzing the atomic structure of crystals and their properties. We will explore the significance of these planes and their implications in material science. What are HKL planes? Let us discuss. Let us discuss about these HKL planes. HKL planes represent a set of crystallographic planes in crystal lattice, and each plane is defined by its Miller indices, which indicate its orientation, and these planes are vital for understanding diffraction patterns and material properties. Understanding Miller indices. Let us try to understand what exactly is the Miller indices. Miller indices are a notation system in crystallography which is used to define the orientation of planes. The indices h, k, l denote the intercepts of the plane with the axis of the crystal lattice. This notation simplifies the analysis of crystal structures, crystal lattice, and unit cell. Let us talk about the crystal lattices and unit cells. A crystal lattice is a three-dimensional arrangement of atoms or molecules. The unit cell is the smallest repeating unit that defines the entire lattice structure, and understanding the unit cell is essential for determining the spacing of HKL planes. Separation between planes. The separation between successive HKL planes is determined by the interplanar spacing, and this this distance is influenced by the crystal structure and the values of h, k, and l. It plays a significant role in diffraction and material behavior. Calculating interplanar spacing. Let us talk about how to calculate the interplanar spacing between them. The interplanar spacing d can be calculated using the formula, that is d is equal to a by under root of h square plus k square plus l square, where a is the lattice parameter, and this relationship is critical for predicting diffraction angles and understanding the crystal properties. Bragg's law and diffraction. And when we talk about this Bragg's law and diffraction, Bragg's law relates the angle of incidence and interplanar spacing to the wavelength of the X-rays. It is expressed as n lambda is equal to 2d sine theta. This law is fundamental in X-ray diffraction experiments for determining the crystal structures. Applications in material science, and let's talk about the applications in material science of these HKL planes. Understanding the separation between HKL planes is essential in material science as it helps in the design of materials with specific mechanical and optical properties. This knowledge aids in developing new materials for various applications. Impact on crystal growth, and let's talk about the impact on crystal growth of these HKL planes. The separation between successive HKL planes affects the crystal growth rates. Different planes may grow at varying rates, influencing the morphology and quality of crystals. This understanding is vital for synthesizing high quality materials. X-ray diffraction techniques. Let us talk about the X-ray diffraction techniques using the HKL planes separation. As X-ray diffraction techniques utilize the separation of HKL planes to analyze crystal structures. Techniques such as single crystal and powder diffraction provide insights into arrangement of atoms in a crystal. Future directions in research. Research on the separation between successive HKL planes is evolving. Advances in computational methods and experimental techniques are opening new avenues for understanding the complex materials and their properties. And when we talk about the conclusion, in conclusion, the separation between successive HKL planes is a fundamental concept in crystallography as it influences the various aspects of material science from diffraction techniques to the properties of materials. A deep understanding of this topic is essential for advancements in the field. In conclusion, as we know that crystal structures is one of the most important topic in applied physics. In the crystal structures, the Miller indices and the HKL planes is one of the most important topic. And this understanding the separation between successive HKL planes is very important as it is a very fundamental concept in crystallography, and from it defines diffraction techniques and properties of many materials, and a deep understanding is very essential to know about any advancements in this field or any physics topic. And even the scientists and Scientists are researching about these HKL planes and they're trying to discover new things about the crystal structures and Miller indices and the HKL planes as this is evolving and advances in computational methods or experimental techniques are opening new avenues for understanding complex materials and their properties. And in final conclusion, this is very most important topic in applied physics and in crystallography. It is the separation between HKL planes and Miller indices. Thank you.